So at this point, we need to just connect the 2 points that we have. The way we're going to do that is by using a very basic operator, but it's also extremely useful and you'll be using it very frequently as well. It's an add operator. Let me connect this here. An add can do many things, and it essentially, based on the name, you can add different points, establish their position, etc. But in our case, we want to add polygons. And what we're going to do is connect the points by adding a polygon between both of them. And we're going to do that by group. And right now it's saying all points. Since we only have 2, we will have 1 primitive added here. If we middle mouse button here, you'll see now we have 1 primitive. Before we only had 2 points, 0 primitives. And now we have 2 points, 1 primitive. Okay. Now, this is what we're going to be deforming. This should also already, this connection will maintain itself throughout the course of the animation, as you can see. Let's create some room. If you want to template, have a look at the Iron Man. Let's template the Iron Man and template the hammer. Let me hold shift to template both of them. And as you can see, these 2 points are going to be connected. And this is already an interesting effect, as you can see. So we already have an interesting effect, being a line generating from the hammer and hitting Iron Man. But now we need to deform this. So now we need more points. Right now we only have the extremities, and we need these, we want for them to remain at the same place, but we want to have more points in the middle that we can disrupt and create that kind of lightning effect. The way we're going to be doing that is, first we're going to be adding those points using a resample. I'm going to right click here, resample, and let's add the resample node. We've already used this before, and as you know, we can establish a maximum segment length. Okay, so this isn't enough. I'm just going to make sure that the points are more visible. I'm going to hit D, and here on the point marker size, I'm going to say this maybe 10 is too much, but 5. Okay, so this isn't enough resolution for us to have the level of detail that we want, so we're going to be lowering this down to 0.01, and this will give us a lot of geometry. Okay, every 1 centimeter we have a point, and this is going to be good for us. Now, the next step, we're going to be introducing another area of Houdini, which is a graphic alternative to writing code. So far, when we wanted to do something more specific, we were using a point wrangle. But as an alternative, if you're not very comfortable using writing code, you can use a point VOP. They both have their advantages. In some situations, in most situations, I'll prefer to use a point wrangle. But whenever we're working with noises and stuff like that, the point VOP makes it easier for us to have access, or visual access, to all the parameters associated with the noise. So in this case, what we want to do is exactly work with the noise. So we're going to be using a point VOP, connecting this to the first input. Now, just to establish what we're going to be doing, essentially we have all these points. Each point has their own position. What we're going to be doing is adding a certain vector that's going to be generated by a noise, and that we're going to be adding that vector to each one of these points. Okay, so let's say we have all these points, and I generate for each point, I generate a random vector, and then I apply that random vector to the point position, and the new point position is going to be here. If we do that to a set of random vectors generated by a noise, we should get something pretty crazy like this. Okay. Now, notice that I left this point here, but this isn't going to happen unless we need to make precautions to make sure that these points, the extremities, they should stay in place. Meaning that we, besides applying those noise generated vectors to the position of each one of these points, we want to make sure that the size, the intensity, the amplitude of those vectors is controllable by us. So we should have a gradient. Let me change color. We will have a gradient that goes from one point to the other, saying that here we will have a value of 0, and here we will have a value of 0, and this will have kind of a gradient. So if we were looking at a graph, we would have something like this, meaning that there will be no displacement of the points on the edges, and there will be a lot of displacements on the middle, and then no displacement again. So it'll be a combination of all these things. We'll have random vectors generated for every point, but these vectors are going to be multiplied by this gradient, okay? Meaning that this vector, even though the vector was generated with this size, it's going to be multiplied by 0, so the point is going to stay here. Here the vectors were generated with a certain size, and they're going to be multiplied by 1, so the offset is going to be of that intensity, and so on and so forth. So this is just a quick review over what we're going to be doing. Let me hit escape. Here on the resample, I forgot to turn on one very useful thing. It's going to come in handy. Remember, we've used this before, which is the curve view attribute. The curve attribute is going to be generating a new attribute on our points, and that attribute is going to be going from 0 to 1, from one extremity to the other, and we'll have every point will have an intermediate value. Let's just have a look at here before we apply the resample. We can check the number of the points. So right now we have 0 there and 1 here. It's absolutely no problem for us. That's totally fine. But this just means that when we apply the resample and we tell Houdini to calculate the curve view, we'll have a curve view value of 0 and a curve view value of 1 here, and the intermediate value. So it's going to be growing on this direction, but that's totally fine. Let me turn off the points, resample, point VOP. Let me hide the number of the points. Let's check that we actually have our curve view attribute, as you can see here, going from 0. If you click on it, it's going to change the sorting. So it's sorting from the maximum to the minimum. If you click on it again, it's sorting from the minimum to the maximum. And as you can see, it corresponds to the number of the points precisely. Now that that's done, we're going to dive into point VOPs.